The Amazon's black gold assumption was simple and seemingly obvious. The Amazon jungle was dense, the vegetation was extraordinary, the biodiversity was staggering. And so the soil beneath it must be extraordinarily fertile. It is not. The soil of the Amazon rainforest is among the most nutritionally poor agricultural soil on Earth. Almost everything that makes the jungle so spectacularly alive is locked up in the living biomass of the forest itself, not the soil beneath it. The soil is almost empty. The moment that biomass is removed, as happens when rainforest is cleared for agriculture, the thin nutrient layer at the surface is gone within a few growing seasons. What remains is a pale orange soil so poor in organic matter, it can barely sustain crops at all. This is why slash and burn agriculture in the Amazon has always been a cycle: clear, burn, use for 2 or 3 seasons, abandon. The jungle recovers slowly over decades, and the farmers move on to 1,000 years of this cycle. Always the same answer, always the same limitation. Modern industrial agriculture in the Amazon faces the same fundamental problem, solved at enormous environmental cost through continuous heavy application of synthetic fertilizer that the thin soil cannot retain, and that run off into waterways, causing significant ecological damage. The soil always wins, every time. And yet, scattered across the Amazon basin, there are patches of soil so extraordinarily fertile, so dark, so rich in organic matter, and so sustainably productive, that they have been continuously farmed for an estimated 2,000 years without significant degradation. This soil is Calaterra preta do Indio, dark earth of the Indians, in Portuguese. And it was made to be human hands, not naturally accumulated, not the product of geological processes, deliberately manufactured by pre-Columbian Amazonian civilizations using a combination of materials and processes that mainstream soil sciences still not entirely sure how to replicate. Normal organic matter added to soil, whether compost, manure, or crop residue, decomposes rapidly in the hot, humid conditions of the Amazon, releasing its nutrients, but also losing its structure within a few years. The enrichment is temporary. In terra preta soils, the organic matter does not decompose in the same way. It persists, it accumulates, it builds on itself over time, producing a soil that gets richer, rather than depleted, with continued use. 2,000 years of farming, still productive, still improving. A soil that responds to use becoming more, not less. The key difference is charcoal. Terra preta contains extremely high concentrations of charcoal, produced from organic materials at specific temperatures and in specific conditions that produce a highly stable form of carbon known as biochar. Biochar does not decompose the way normal organic matter does. Its molecular structure is resistant to microbial breakdown, meaning it persists in the soil for hundreds or thousands of years, rather than being consumed within a growing season. It stays, it works, for millennia. Biochar is not just chemically stable, it is chemically active. Its highly porous surface structure provides an enormous surface area for the attachment and retention of nutrients, water, and the microbial communities that make nutrients available to plants. A sponge and a scaffold, simultaneously, for 2,000 years. In normal Amazonian soil, nutrients added to the surface wash away, or are consumed by decomposing organisms before plant roots can access them. The tropical rainfall is relentless, the leaching is constant. You add nutrients, the rain takes them, the roots get almost nothing. The biochar in terra preta acts as a sponge holding nutrients against leaching effect of tropical rainfall and providing the structural habitat that supports the dense and diverse microbial communities that healthy agricultural soil requires. The rain falls, the nutrients stay, the roots feed. The ancient Amazonians created terra preta were not doing this because they understood soil chemistry. They had no concept of molecular structure, no understanding of microbial ecology. They were doing it because generations of agricultural practice had taught them empirically that incorporating specific types of charred organic material produced soil that remained productive across many generations. The specific combination of materials found in terra preta is distinctive. Biochar, bone fragments, pottery shards, organic waste, food scraps, fish bones, manure, and high concentrations of phosphorus and calcium, whose source points toward deliberate incorporation Rather than accidental accumulation, this was designed, not deposited. Some researchers have proposed that terra preta was produced as a byproduct of settlements, rather than as a deliberate soil amendment. That the dark soils formed naturally beneath long-occupied habitation sites, where cooking fires and domestic waste accumulated over centuries. But the distribution pattern does not support this. Many deposits are found in configurations that suggest deliberate agricultural soil construction rather than simple settlement waste accumulation. And the consistency of the biochar content across terra preta deposits from widely separated regions suggests a shared knowledge tradition of deliberate soil construction. Not accident, knowledge, shared, applied. Dutch soil scientist Wim Sombroek, who spent decades studying terra preta and became perhaps its most important modern scientific advocate, argued from the evidence of large-scale and deliberately configured deposits that the ancient Amazonians were engaged in systematic, landscape-scale soil engineering, a deliberate long-term program of soil construction that transformed large areas of infertile Amazonian Lateral permanently productive agricultural land. If Sombroek was right, and the evidence he accumulated over his career makes a compelling case that he was, then the pre-Columbian Amazonian civilizations were practicing agricultural soil engineering was scale and sophistication as no equivalent in the ancient world. Modern agriculture is facing a soil crisis. Intensive industrial farming has degraded topsoil across enormous areas of the world's most productive agricultural land. Soil organic matter depleted. Soil microbial communities disrupted. Soil structure damaged and the biological functions that healthy soil should perform in its own, now substituted by synthetic inputs. The Food and Agriculture Organization of the United Nations has estimated that if current rates of soil degradation continue, the world has roughly 60 years of productive topsoil left. 60 years, after which the agricultural foundation of human civilization begins to fail. And the modern agricultural research community is actively looking for solutions to this problem. Biochar has been identified as one of the most promising approaches. Researchers around the world are testing biochar applications in degraded soils across multiple climate zones. The results are consistently encouraging. Biochar additions improve water retention, improve nutrient availability, support beneficial microbial communities, and as its long-term stability implies, provide a persistent soil improvement, rather than a temporary fix, not a treatment you repeat every year. A transformation you make once, that lasts for centuries. Biochar production and application is being discussed seriously at the level of climate policy as a tool for removing carbon dioxide from the atmosphere and storing it stably in agricultural soils for centuries. A soil amendment, a food security solution, a climate intervention, all at once. And the entire foundation of this research program is an agricultural technology that pre-Columbian Amazonians developed and practiced at landscape scale 2,000 years ago. The cutting edge of modern soil sciences and ancient Amazon solution. Arrived at from completely different starting points, arriving at the same answer. The modern research did not start with ancient Amazon soils as its inspiration. It started with soil science and the search for sustainable solutions. And it arrived independently at the same answer that anonymous ancient farmers in the Amazon arrived at through generations of empirical practice. Two paths, same destination, 2,000 years apart. This parallel discovery suggests that biochar-enhanced soil management is not just one possible solution to the problem of agricultural sustainability. It is the solution, the one that works in the long term, the one that chemistry and biology of soil health point toward, regardless of what starting point to come from. And it was already known, already practiced, already proven. The ancient Amazonians were controlling biochar formation temperatures, managing soil microbial structure, engineering nutrient retention systems at the chemical level. Without knowing any of those words, just knowing that this produced better soil than that, and passing that knowing on, the pattern again. Sophisticated technical achievement, developed through purely empirical means, over a very long period, without theoretical understanding what was actually happening at the level where the effects occurred. Controlled without being understood, mastered without being explained. Lost when the chain of transmission broke, the modern world is only now catching up. Not leading, not innovating, catching up to a solution already proven, already deployed at landscape scale, already producing results for 2,000 years before anyone in the modern world knew it existed. The soil remembers. 2,000 years of accumulated biological intelligence encoded in the pore structure of biochar, in the chemistry of bone and ash, in the microbial communities that have called terra preta home across 100 generations. The civilization is gone, the soil is not. The dark earth is still feeding the Amazon today, not as a relic, as a working agricultural soil, producing crops, sustaining farmers, outperforming modern alternatives 2,000 years after the civilization that created it was erased from the earth. The soil outlasted everything, the research funding being directed toward biochar as a soil amendment and a carbon sequestration tool is now significant. Climate conferences, agricultural research institutions, United Nations policy bodies, all arriving at the same place. The same black soil, the same ancient answer. No modern soil amendment does a 2,000-year track record of proven performance. Terra preta does, in one of the most challenging agricultural environments on Earth. Against tropical rainfall, against nutrient leaching, against every pressure that destroys normal soil, still standing, still working. Sometimes the greatest agricultural revolution in history happened in a jungle 2,000 years ago, and the modern world is only now catching up. Not finding a new solution, rediscovering an ancient one that was already proven, already working, already 2,000 years old when we found it. Without molecular chemistry, without soil science, without analytical tools of any kind, anonymous ancient farmers in the Amazon figured out how to make dead soil permanent, how to make infertile land fertile, and keep it fertile for 2,000 years. Through watching, through doing, through passing it on. Still patient in the Amazon forest floor. Still dark, still rich, still productive. Still demonstrating every day that the ancient Amazonian shad figured out something that the most advanced agricultural science in the world is only now beginning to understand. The soil is waiting. It has been waiting for 2,000 years. The jungle concealed it replaced. Roads, causeways, raised fields, settlement mounds, and millions of square meters of carefully engineered dark soil, still doing its work beneath the roots of the trees that grew over everything. The wilderness is not pristine, it is a memory of a world that was building and monogging and feeding itself with extraordinary sophistication in a jungle 2,000 years ago. A world that was erased so completely that the people who erased it thought they were finding wilderness. They were finding ruins. The answer to the modern soil crisis was already there. In the Amazon forest floor, rich and dark and patient. While researchers spent decades searching for a soil amendment that could persist, that could improve with use, that could resist leaching, the answer was sitting in the ground. 2,000 years old, already proven. The black earth still feeds, still outperforms, still improves. A gift from a civilization that no longer exists to a world that is only now learning to read what it left behind. The soil is the message, and we are finally beginning to listen. For more ancient mysteries and hidden histories, subscribe and keep exploring. Because sometimes the greatest agricultural revolution in history happened in a jungle 2,000 years ago, and the modern world is only now catching up. Until next time, stay curious.